My name is Scott Tuddenham. I work for a small merchant bank out of New York. We do alternative lending. Won't get into that specifically today, but that gives you some context for where I'm coming from with what we're dealing with. I've been developing in Clojure for 4 or 5 years, been a software developer for 10 years. I'll get into that. Part of the agenda I'd like to talk about today is to just say, hope this presentation goes well, that you guys can get some useful information from what I'm going to provide, that I can just give some high-level talks. On the heels of Rich's speech, or his talk, I've shifted the focus away from what I was originally going to talk, which is a deep dive into specifically some of the semantics of how we get to extract information out of documents, to a framework on which to build this thing which can extract documents. So definitely more information about kind of the middle of the sandwich, if you guys catch that. And yeah, then I'll just walk through what we do, how we do it, how we build up this body of knowledge to gain understanding about documents and how that helps our business. And then I'd like to leave some time for questions. So hopefully that you guys can take from this just some helpful hints of this is an experience report of the way that I chose to do things. It's not right, it's just the way that I thought and processed through and iterated to develop a solution that our company needed and something that I'd been working on kind of tangentially outside the company. So if you can get something from it, some patterns that you can choose to follow, I'll build some of the framework stuff. So definitely some of the things that didn't work, so I can highlight what didn't work and what you shouldn't do. What we really try to do is just have like constant iterable deliverables. So saying, here's a small piece of functionality, here it is, you can go and use it now, even non-technical people. That's always been my purview, is like, don't build this crazy, convoluted, large, complex system that's half-baked and doesn't work, but instead, just get one thing out the door that does it and does it well, and give a contract for saying, yes, this works, and it's good, and you can use it, and here's some documentation around it, and it's not going to change because it only does the one thing that it's ever going to do. So what we really want to get to for this talk is to say, I have a means by which to say, we're working with documents all day, every day, business documents, arcane legal documents, business financial statements, all kinds of different documents. You know, the piece of paper takes a form based on what's written on it. Sometimes we know exactly what's coming over the door, sometimes we don't, and so it becomes very, very important to understand all that document contains, what's in it. So you want to take what we've learned from that thing and apply it back to itself and then to other disciplines, and I'll get into that some more. Hopefully build on what I've done, and then if you learn something, that's great. Just show of hands, who in their course of business or daily life deals with primarily, or as a subset, documents, right? Pieces of paper with stuff on it. Like, that's what your business deals with, like it or leave it, kind of, sort of. Some people, web services companies, you know, the more old school companies, the more, right, things are still on pen and paper, there's still contracts. We get a lot of those, often as PDFs, so we're ripping apart PDFs to get the information that's buried within them. So who has APIs that they use as you're either consuming or exposing? If you keep them up, just show of hands. All right, so it's this guy specifically. All right. It's been my experience of integrating tons and tons of APIs that it's often a pain in the ass. And people that claim they have an API endpoint that does a certain thing may or may not actually do that until you start banging on it and learn from what you get back. Even well-established companies that have well-documented APIs, it still lies to you. And in integrating lots and lots of APIs, I've developed a pattern which hopefully we can use here that basically provides a contract for defining what it is and saying, here it is, you can use it, here's the specs around it, and it's good to go, and you can expose it so you can integrate it and know that you're going to get back what you actually asked for. All right, so quick background about me. I can tell you that I was not a programmer to begin with. I was not even considering it. I was going to go to law school. I minored in comp sci just kind of on a whim, but actually had a degree in philosophy and political science. Was going to go to law school, was working at a law firm, and we were dealing, it's a mass tort firm, dealing with millions of documents. We literally had trucks come in to shred all the documents, and just dealing with millions and millions of documents and trying to build enormous mass tort cases around all the information that may or may not be buried in document discovery. And often they'll just, if some defendant doesn't want it, some major firm floods the firm with everything, hoping that that red herring will be buried in the details and you'll miss it because the sheer volume, right? It's just too cost prohibitive to actually go through everything. And there was people on staff that whose jobs it was to code. And by coding, I meant go through a document and find instances of things and tag it. And although the case was interesting, that job was something that I wouldn't wish upon anyone. But yeah, so that worked for a while. I left that, got interested in a startup that worked on, saying, a social enterprise that said, here's some information, here's a website you're interested in. It went and ripped the information out of that website, went and found other websites that were similar, fed those to you as recommendations. So it was definitely a social recommendation thing. Kind of didn't work till the end of 2008. As everyone remembers, the financial crisis, that got me deeply interested in how the financial markets were working and understanding how things became correlated. And I'll speak to that in a little bit later. Why it is the case that things become correlated and finding correlations between things, even when they don't actually exist. And I use air quotes for a reason, is to say, yes, there is a statistical correlation between A and B, but it doesn't really exist. And as we hand over things to machines, I'll throw a word of caution for what that means when you're saying, okay, there's something in this document that's related to something else, but it doesn't actually mean anything other than they just occur kind of close to each other. So what we're dealing with when we're trying to, say, extract the knowledge from a document, it's really dealing with three branches of philosophy, and to steal something from Rich, to unpack the words that we're using. So the ontology of something, which is, to be metaphysical, the nature of it or the being, what is it that it is. The epistemology of it, which is the theory around the knowledge that it contains. So something is within it. If you have a document, it has knowledge embedded within it, not specifically within the text that is there, but some expert looking at that document knows more about what is in it than someone else. And so that knowledge needs to be captured in some way. And that's really the value add, is to saying, take a look at one simple thing like a financial statement, as boring as it is, applied from the viewpoint of a skilled, trained financial analyst. And there's knowledge there that can really be gleaned and understood and processed. And so that is the game, to say something, to take it, rip stuff out of it, and apply more stuff to it based on the people that are looking at it. And how can we take what they've looked at previously and apply that further so the next time it's even smarter. So getting onto pedagogy, to say, not only are you dealing with the thing, you're dealing with the method by which you've trained it so that you can have it be smarter the next time. So the conveyance of the knowledge that was gained is another important facet of what we're doing. This talk is the techniques that I use to get the job done for what we needed are fairly rudimentary. I'll get through some of the nuts and bolts of it. But I'll be the first to admit that if you're looking for kind of the leading edge of NLP and machine learning and understanding and that game, there's definitely an interesting talk that was given at Clojure Europe just a few weeks ago that really gets into saying he's basically providing a language definition for understanding Polish, which is an interesting language itself. But there's definitely other documents and other talks to get to the deep learning aspects or the machine learning ways of doing this thing. We have kind of the crude version that gets the job done, but I'll say that what I'm doing here is going to be supplanted by these techniques in the future. It's kind of a no-brainer that this is kind of the way things are going. It's not really important to say the actual techniques we're using, but to say, all right, here's the framework by which we did it. So how many of you watched Rich's talk from his hammock-driven development? It struck me in a way that was kind of, I didn't really process until he kind of let it digest for a while. I guess sit in a hammock and watch it. Extending that one further to say, let's have a way that I've kind of developed internally for our company is basically README-driven development, which is to say, here's a contract out front and center that defines exactly what the thing is. And you're designing it from the viewpoint of who's going to consume it. And that does a number of things for us. It really grounded and centered what we're actually focused on delivering. It also made it designed in such a way that you're actually thinking about the end user and caring for them and saying, okay, if you can't understand it, then you're not going to use it. And if you're trying to build a library, as we all have these great open source libraries that I've fully leveraged, like just basically the README as the means by which to say, here's the thing that it is, and it's going to be no more, no less, and you can reference that as the contract by which to use this thing. So this thing, a library or framework or whatever it is. We found that just kind of taking that approach, kind of ad hoc, I just kind of said, like, here, let's build the README and then make that README truth. Right? Let's say it can do a thing and then actually build it so it can do that thing. It also helped me get the discipline to really only produce the code that we could actually deliver, not some spurious body of a system that we might use later down the line that might be useful. It's all right. It's a real thing. It does what it says it's going to do, and it's good. I mentioned giving thanks to things. We're basically just composing a bunch of different libraries together. If anyone's not familiar with these, I'll just quickly run through them. Liberator is our bread and butter for exposing everything as a RESTful resource. Biddy, great library to do routing as data. I'll get some more slides on that. Buddy also, it's in the financial realm. It's very important to be secure, so we have bank level security. That handles the tokenization, the authing, secure encryption and hashing of all the passwords and all that stuff, and also the documents themselves being encrypted. HTTP Kit to serve it all up. There's a blog post handling 600,000 concurrent requests. It's good enough for our purposes. It works. Byte streams, we're streaming out data. We're also pulling it in. Mostly we're dealing with multi-part form params. It's just raw data. So as soon as it comes across the wire, it's coming in a number of different formats. We're using that to ingest. Cheshire, because we live in a world of consuming and producing RESTful JSON APIs. So our language du jour is obviously JSON. And so we're handed documents, and often I'm spitting back JSON. So give me unstructured documents, I'll rip out the text and give you back knowledge and the actual text as data formed up as a JSON document. And so you can take that and do what you want with it, process over it, compose over it. We consume it internally. We pass it off to another system that I also wrote. The fuzzy CLJ stuff, great thing for the text pattern matching. That's basically gets into how we actually pull stuff out. Core match, use it in its crudest sense. If it has a certain conditions, if it matches this, then the answer is here. So basically answer in, give me the possible ways to get to that answer. So we have loose, flexible rules that we're not quite sure what we're going to find. But if we find certain things, then it has to mean this. So there's definitely a lot more interesting use cases for core match. We're using basically just match on these conditionals. Neocon's our backstore. We use a graph library called Neo4j, if you're familiar with it. That gives us a lot of nice properties. Really nice properties, really easy to semantically define the relationships between things. And we weight those relationships between, there's some piece of information, here's another piece of information. They're somehow associated, they're somehow related. Not quite sure, but if you weight it and you just define the relationship, any future time that comes up, you just say, all right, give me that node, give me everything that's associated to it in some way, and then you're provided more contextual knowledge about the thing that you found. So each time it finds it, it just forms more associativity, and then it gets crazy. In the kind of the way the brain works is it forms connections, and you're not fully sure how it formed the connections, but the fact that they're there has some meaning, so surface that. That's all it really is. Meltdown, we have an efficient message parser. It's a message bus. Everyone's got one of those. I just choose that because it's from the finance industry. LMAX, really performant message bus. Produces and consumes messages. It's solid, rocks, I gotta use it. So yeah, just quickly saying, I want to have an architectural definition. This is more a way of composing any type of RESTful API. It happens to be a means by ripping apart documents and getting into them, but it's also something that says, okay, I'm handed anything, and I want to provide utility for it. And so this is basically, kind of the way we handle things is you take these small composable units and we string them together in some way. And I come from the JavaScript land, and frameworks are the name of the game all the time, and you kind of have to buy into their beliefs about what that framework dictates. And it always works until you want to do something slightly different from how the authors intended you to use the framework. So one of the things I absolutely love about Clojure is the notion of those small composable libraries that you just build up however you see fit as you need. I like to use the analogy. One of the things when I'm not coding is climbing. And when we rock climb, you build up anchor systems of small independent pieces, protection, and you string them together in such a way that it's distributed and equalized and redundant and solid. So you want to check those things before you place your weight on it, because if you don't, the consequences are genuinely dire. You can fall to your death. And the worst thing that can happen if you mess up the composability of some functions, I thought was just you get a null pointer exception instead. But hearing these talks, guys monitoring diastolic blood pressure in an ER, like this code, I guess, really genuinely has to work, and it has to work perfectly. And sending code into deep space, I love it. It's crazy. One thing we like to use is Biddy, and the reason I like to use Biddy, I grabbed this from the site. There's multiple routing frameworks you can use to be able to process requests, and the reason it shows Biddy is specifically for this third column. The syntax is data, and it's really, really nice to have all of your endpoints not hard-coded into the application the way that if anyone's used to Django or Python or Node.js or even Express, you kind of have to hard-code all these endpoints and conditionally match on anything. But when you say, here's all of your endpoints itself as a data structure, you just say, OK, all of your handlers can be functionally composed over. And so what we do is rip out all of our API endpoints to be able to handle different types of documents and different semantic understandings and different pattern matching things on our internal APIs. We expose that, and we say, literally, here's this data structure that is all of our endpoints, and we can push that outward to the README to say, here's how you can consume everything that I've produced, and also we're using it referentially internally as well. So it's the same source of truth, both externally for how to consume it, and internally how we actually match on when something comes across the wire, what I deal with it. It's kind of nice in the sense if anyone's familiar with building up HTTP requests in Hadios or hypertext as an engine for state management, saying, all right, I give you a request. I'm going to send back to you all the other requests as links of what you can now do. So if you authenticate, I give you a response. Now that you're authenticated, you're now allowed to hit these other endpoints. That's kind of a nice thing. It gets to a contract where you're saying, I'm going to offer you something. I'm going to require something from you, and that's all programmatically defined. So it's not ambiguous. You're not going to all of a sudden break something, because it's just there, and it's very, very nice is the only way I can describe it. It's just a loose, flexible way to deal with things, and it's rooted in a data structure, so everyone can understand that very well. The way we handle all the documents is as the conveyor belt analogy. This is a lot of well-worn in Clojure, is just jamming things on a message bus. It tries to do as much as it can with that document, and then feedback as much as it can. So initially it was not very smart, got smarter over time. So the request comes over, rips it apart, applies its knowledge that it can, pulls the text out, structures it in some way if it knows what it's looking at, and provides not only the text back as structured data, but all the extra information that it could glean about that and all the associated stuff that comes with it. So the first pass of it was literally like, OK, can you give me a random document as a PDF, and can I give you back the actual information that's buried within it? So we take Liberator and apply it kind of everywhere. It's a notion of just saying, there's some functionality that we need, expose that as an API endpoint. And I've done it in other languages, and it's ridiculous. Liberator, and specifically Clojure, makes it really, really nice, and I don't want to say easy, like almost trivial to say anything that you want to have. If your team has some other binary application, you can just expose it as a resource and have very fine-grained control over not only who can access it, how they can access it, what's required of them to access it, what they're provided when they do get it, and all the methods you can hit on it, and what it's going to give you back. And that's all just defined right there in one little function call as def resource. So we definitely just say, here, post to this endpoint that's all documents, and then it goes to town and tries to figure out what's going on. One thing that, just a little gotcha, we remembered to have is we're basically using third-party binaries and some lower-level Linux programs. So it's nice to be able to say, all right, target what you're doing. So we had the issue of, well, it works now, why doesn't it work over there? You've compiled for one architecture, it doesn't work for the other one. Just the thing to remember is saying, yeah, following Rich's steps, just it tries to do the right thing. And one aspect of that is, all right, are you even using the right architecture, the right program on that architecture? So yeah, if you got a DevOps team and they're like, you built it on your MacBook, but now we're putting it in production in Linux, those issues do come up. What we're essentially doing is shelling out. So there's the built-in Clojure macro, sh. It basically spawns a new thread, and you provide it all of the arguments and the binary that you're using. We leverage this pretty heavily. We tried first implementing a lot of third-party, enterprise-y, expensive solutions where you hand it to them and then you get back like in emails or stuff. And what we actually found is that the lowest level Linux primitives were more efficient and better at being able to extract out the information. So in that vein, A, it's free, which is nice. B, it's faster, so we're not relying on some third-party service where it has to go and have some contract. C, we can mix and match and compose exactly how we want. So it's nice in that regard. And there is some learning curve to it, but it's not that crazy. You just read the doc and you can see how to use it. We're basically embedding binaries. So if anyone on your team we're particularly using a PDF to text extractor, basically, or an image to text converter. But whatever logic or program or business thing your company has, if they had some guy that built a Go binary or a Python script or whatever it is, that can live within or underneath this like grand Clojure architecture, which is kind of nice as well. It's like, yeah, you have your thing and it does its thing. Okay, just as long as it provides a piped output in the grand Unix style, then that's all we need, and we can embed it into our application. So we have this kind of living as a meta layer on top of some other programs. So it's basically, if you want to expose a resource, it's actually exposing an under-the-hood binary application that's just piping it in and grabbing the result and feeding it back. When we take text out of a PDF, the PDF to text is literally the best and most efficient means. Sometimes it doesn't get all of it, and so what we have to do is break it up into images. And when you break it up into images, there's a program called Tesseract that was originally out of HP Labs. It was built initially in 1984, so it's been around for a little while. They gave it up in 2005, open sourced it. Google took it over in 2006, and it's now kind of emerged as the de facto best OCR. So if anyone's not familiar with optical character recognition, it's basically, can you look at an image of something that looks like a 9, and is it in fact a 9? And imagine that over hundreds of pages of dense arcane documents. I give you something, can you give me back what it actually is and not screw up? So there's some games to be played with it, but it does do the job. That's all I can say, and much better than even Adobe Acrobat or any other, actual full-fledged programs that claim to convert from one format to the other. Basically, we're interested in whatever the document is, just get it to me as text, and then I'm going to compose over it a lot. What's important for how we define the knowledge is a number of different pieces. So what we have is what we've built up as a corpora, or multiple corpuses of knowledge, and that knowledge lives separately from the actual document. In that knowledge, there's no magic to saying there's some ontological understanding of the document. It's just, okay, is there a node that has a term that has a relationship to some other term, and does that occur frequently? Let's recognize that. Let's define some basic patterns that you can find in any clausal contract document. It's okay, whereas this with the parties here in the state of, summing the total of. If you know the loose structure of a document, you can start to apply patterns to regex through those things to grab what you want out of it. And then when you have that, you can basically just slap on all these knowledge pieces that you've gained and say, okay, here it is. And so there's some other things that we use. And so when you have all this built up corpora, apply those corporas to the data. And then so we're basically just literally mapping and composing over and building up inferences from what's embedded in the documents. Again, there's knowledge types. There's nothing fancy. It's just nodes, relationships, patterns, groupings, and rule sets. We just simple rules. If you find this, it means this. If you know that it starts here and ends there, then it has some meaning you want to capture, specific financial clauses, bank statements, that kind of stuff. What we've defined as the frequently accessed qualifiers, or things that don't quite fit into any of the categories, but it's interesting information and we want to get it. So it's a bit hacky, but here's a thing, here's a term, here's a section, here's a pattern, here's a whatever. When you encounter it, if you encounter it, do some extra conditional logic. In our case, it's basically when you encounter a business name and the owner, go out and pull that information from another API that we have. So, just kind of building up, okay, when you're handed something, I can recognize that, I'm going to go and grab this other thing, pull it in, and give it both back to you. That's all that's happening. It has to be flexible because it doesn't always know what it's going to get. So we built it in a way that it doesn't break if it doesn't find something. So you're never going to get a null pointer exception. It's just going to say, yep, couldn't find it. And the first time it was, well, it should have found it. It was just too stupid to know what it was doing. It couldn't correctly identify certain things. Through iteration, we're saying, okay, first pass, it didn't work, but it should have. Now it kind of finds it some of the times if it's very generic. Then it can build up to more complex, multivariate scenarios where it's genuinely handling cases of documents that are complex legal documents that have variable amounts of clauses and terms in them that need to be captured correctly. And so it basically, again, just composes over things and says, apply this, if you find it, give it back. And then for our non-technical guys, just built a simple UI to say, okay, let's have them feed it more information, and so the corpora can build genuinely a knowledge base of saying, okay, I'm encountering this thing a lot, this term, this clause, this phrase, whatever it is, this number often. When you find it, it means the following, and then that's a simple form that they can hit, and then that adds to the registry of information that can then be applied to all future documents. So each time it's being used, it's getting a little bit smarter, and I don't say smart because it's not intelligent in the AI sense, it's just less stupid. Who's ever looked at this book? It's a bit of a treatise on how to use Incanter, but it does have some useful information if you're interested in any of this kind of stuff. We're just pulling out information, doing statistical analysis on the terms it encounters, drawing histograms. It's regular just data science stuff. It's not the most fascinating thing in the world, but I couldn't think to do it in any other language. I come from a background of doing a lot of analysis in R, and R is really good for historical stuff, but can't really do real time, which is more interesting. So that's how I actually got into Clojure in the first place. So interesting tangent. All right, so presuming that you've been handed a document, you get it back, you've got all the information, it's now just a big complex string. We're trying to, as most as possible, just use the built-in functions that are in Clojure to go over it. So I didn't actually, who knows regular expressions to the point where you can actually build up complex regular expressions? Very nuanced cases, and this is the crowd to do it with. I'd always just grabbed one whenever I needed it, got the job done, and moved on, but suddenly sat down and said, let me genuinely understand what's going on to be able to compose over these things and build up these complex scenarios. So literally just using a combination of these built-in primitives to say, all right, seek over something, find it, find the pattern, build up the pattern, concatenate these patterns when you find over those things, return that as a capture group, and when you're finding that, then give it some meaning. So we just have, all right, one of the most important things is how often something happens, and it's just quickly, you guys can discern what's happening here. It's just saying, all right, given a regular expression and some threshold, I want to be alerted to if something happens more than, say, some number of times. So set a threshold, say the regular expression you want to match on. So we have all these built-up utility functions that in concert all compose over the same large body of text, namely this huge document that's parsed as text, to say, now we're just applying, merging it all together to say, all right, here's what's interesting about this thing. Here's what I found. Here's some facet of this thing that you should be alerted to. We're not trying to replace anybody, but give them something that makes their job better. Basically, yeah, just building up regular expression patterns from simple, all right, just find this simple thing. All right, find this simple thing next to this other thing, next to this other thing, next to this other thing. Combine, that means that it's actually this complex clause or this complex financial statement. Independently, it's kind of stupid, but when you start to flexibly compose them, it becomes rather powerful to be able to say, all right, I can go and grab all of these different facets of a document and give them back to you as the known entity that they are, at which point you can do all the calculations and interpretive analysis that you see fit to do. So really kind of interesting if if you like to geek out on this kind of stuff. Our underwriters, and our financial analysts, they just want to say, here's terms, here's terms, here's terms. Tell me when they find it. If I don't find it exactly, then what we really need to do is to say, all right, we have all these terms, we have all this body of knowledge, we have all these texts, that's cool. Not really. But when it doesn't find it exactly correctly, we can't just not use it. We have to make sure that we're capturing it even if it's not fully there. So the flexibility, we kind of have to relax the hard constraints on finding exactly what we're looking for and say, well, if it's close enough, we have all this fuzzy matching stuff. And so this is a library that this guy Funcool, hats off to him for creating it. I don't surmise to fully even know exactly some of the algorithms they're using. I've just kind of read through what it's doing and how it does it, and it gives us a good baseline for saying, all right, if word A and word B are somehow related, or if they're not too far apart, like literally the text, then it's probably the same word. It's just that the OCR messed up and couldn't find it correctly. So we're just getting a dice coefficient, the Lou distance, the Hamming distance, the Jacquard distance, and so what these all do slightly different things, but if you're familiar with text processing, it essentially says how different is one word from another, or how similar, or how many replacement characters would I need to do to get from A to B. And so we found just kind of a arbitrary, essentially, threshold to say the gold mean of 68%, 75, roughly in that range, for saying if a word is close enough, then yeah, you can flag it as saying, no, that's not right, because I'm looking at the actual text, or infer that it is that thing. You just didn't know what the number was exactly correctly. Those combined, we just, just run through all those and basically get the mean of them to say, and do that for every single word, and then say, all right, it didn't find it exactly, but it's pretty close, so it's probably what you're looking for, so here it is, and I'm going to do some math on it, presuming that it was correct, and here's some math on it, presuming that it's not correct. So you can look at the one and choose which one looks like it makes more sense. Internally, we represent everything as a weighted graph, and like some documents, they're confidential, and that's kind of our bread and butter in our company, to say what's going on, and that attribute to say something is confidential. If it's a document, it's not something intrinsic to the document, but it's information about it And to describe it as metadata is kind of misleading to say, all right, it's just things about it that it should be noted, and you can gain information from it by virtue of it having that attribute. And that's another way of saying, like, yeah, okay, it's confidential. What is it about it that is actually important, okay? Combine that with the flag that it's confidential, and we weight things accordingly dependent on that, and then build up this modeling, basically algorithm, to say, all right, based on this document and the weighted graphs of what it interpreted, do you have what you need to make a decision? I chose kind of an architectural style of separating the knowledge that we have about each type of document from the actual application logic that implements that knowledge. And that gives us a number of things. One, that knowledge becomes persistent because it's literally stored out in a graph. Two, it separates it so we can say, okay, you've built up this body of knowledge that our experts have looked at and used and added to, so it's kind of smarter. We can take that knowledge base and say, okay, it's comprised of what I mentioned before, the delimiters, the patterns, the queues, the relationships, and say, and tack that on top of this document. So you have this historical knowledge base about documents in general that's, well, in our case, very domain specific, but builds up and says, okay, now it can pull out a lot of stuff from what was otherwise just a simple, straightforward document. Separation of concerns, that kind of stuff. It's just, it keeps it clean in that regard. And so one can shift it out. And what I'd like to hopefully see, just as a hope for the future, is that as more general purpose knowledge sets can be attained in some pattern that's roughly analogous to this, and definitely some more interesting ones about machine learning, to open source those to say, okay, you've got this knowledge base about the documents. Well, they did some research into this knowledge set about certain types of information. Somehow combine those and pull from both of those to have a genuine shared collective knowledge that kind of lives ethereally out in GitHub, to say, all right, let's pull the machine learning results from applying something and be able to pluck that and apply it to a different set and see what happens. It's a different pattern of thinking about it, and I've tried to keep those things clean in that way, to say, all right, let's repurpose what we're using, and to say, can I pluck something from a financial document and a legal document, and they're two different disparate knowledge sets that have two very, very different formats, but they have some similarities, and so can we pull from knowledge of both that maybe some other company or entity or person created and apply it to what we're working with? And I think maybe as a way forward to say, here's a contract for understanding what that information is. So I'll wrap it up right there. I want to say huge thanks to the community. You guys make my life fun, right? Like, you guys write these libraries that I think I wouldn't know how to do this in any other language. And for a while, I actually genuinely gave up programming because I thought I didn't want to spend my life fixing CSS style sheets and writing some crappy code that was only going to be looked at by a certain number of people. But the kind of things we're doing, this was just kind of a side project within our company that I personally did in a couple days, maybe a couple weeks, to just build up this thing that we needed to get done. And I couldn't actually think of any other way to do it other than in Clojure, having looked at alternative ways of approaching the problem. So, like all good documents, that's the end. Thank you.